Welcome to Code Corner. This is a video series that we like to do here at Mayfield Renewables that talks about different codes as they relate to solar and solar plus storage projects. And so today we're going to talk specifically about the National Electrical Code and the 2023 version, talking about the scope and the definitions and kind of what some of the changes that happened in the 23 version. So first off, the scope itself didn't change, and so when you go and read this language, you'll see it's exactly the same as the 2020 version. And what you will notice though is the images changed and some stuff around the definitions has changed. So again, just real high level, the scope of Article 690 is talking about basically everything revolving around PV systems, specific to PV. If we're going to look at interconnection, we're going to be pointed to 705. If we're looking at ESS systems in National Electrical Code, it's going to point us over to 706. So the code, the scope of 690 is purely around solar and PV systems. Now, one of the big things that has changed, and this is a universal change within code, is the definitions for all of the articles got picked up and moved into Article 100. So if you're familiar with the layout of code already, Article 100 is where all of the general definitions have always lived. And within each individual article, there were specific definitions that really only pertain to that article. The code making panels decided that the definitions should all live in one location. And so now if you're looking for any sort of a definition, you're going to go look in Article 100. So 690.2 is where those definitions used to live for PV specific systems. And so we're going to go look at them in Article 100. There's two here that I wanted just to highlight, bring to your attention in this very specific case. There's multiples that is worth going and looking at, but these two very specifically, because they relate to the images we're going to look at here in a minute. But the two that were changed, one was changed, one was an add. So PV DC circuit, comma source, so a source PV circuit is really, it's the conductors between modules and from PV string circuits to or DC combiners to electronic power converters or DC system disconnecting means. So the reason why this is a noteworthy change is the code is now calling, basically if the circuit is originating from a PV array, from a PV source, then it's a source circuit. The change here is that we no longer have source circuits and output circuits. So there was a deletion of output circuits. And so in this image we're looking at on the slide here, we have source circuits on the input side of the combiner box, and we have source circuits on the output side of the combiner box. We're no longer delineating between source and output. It's, when you think about it, it's a little bit clarifying. It's helpful in the sense that the source of those circuits is PV systems, regardless of how many are put in parallel. So kind of this input output was always this thing that we had to be really careful of and be talking about. And in reality, we weren't treating them any different anymore in 2020 code or anything. So now we're just calling them really the one and the same thing. The other definition that we have here is for a string circuit. And this is code now using industry jargon really to define what a string circuit is. So we've been talking about string circuits for a long, long time in the PV industry. And so now we finally have a code definition. So we have a way of defining what a string really is per code. And really it's what we already know it to be. It's some number of, it's the conductors that are connecting modules in series. That's all it is. It becomes a string circuit. The interesting thing is when we look at the definitions, when we look at the images that 690 now has, so those changed in 2023, so it's worth going and looking at. And it's reflected here in this slide is string and source circuits really are one and the same thing. So they're equivalent in the eyes of code. So these next few images that we have, these are pulled, or we modified the code versions. And so this is really everything that you're about to see here is based off of the code images. So we still have a module and we still have a cell that's still getting called out within code. But the difference here in this, and so these are the 690.1, it's truly an informational note. It's a figure one in there that shows us these. So truly an informational note. It's just there for informational purposes, but it helps illustrate what code is talking about. So again, PV string circuit, PV source circuit, as you can see in the image here, one and the same thing as it's defined by code, and how we're going to treat it later on when we get into voltage calculations, when we get into current size or current calculations in ampacity calculations. So the way that we're treating those is really very, very similar. And then again, this is, I pointed this one out. This was the first slide that we were talking about with the definitions. And what we've done is, or what the code making panels have done, is eliminated that output circuit. So we have string or source circuits coming in. We have a source circuit on the output side of that combiner box. Hopefully is a little bit more clarifying. It helps just ease things, streamlines when we're talking about what those requirements are. And really, again, we haven't treated those circuits any really differently in terms of circuit sizing or calculations or anything like that. So this is just helping. Hey, it's a PV circuit. It's the source is from a PV array, and so that's what we're going to call it. Then the other ones in that the images that we have here is the DC to DC converter circuit. If you look back in the 2020 definitions, if you look back in specifically, we get into 690.8, which we have other videos that we talk about that. But there's a difference on the input circuit versus the output circuit. So just like with the PV systems, we're just going to get away from those, and we're going to say if it's a DC to DC converter circuit, that's what it is. It doesn't matter really where it comes into play, coming in or in on the input side or the output side. One thing that's worth noting here, this is, again, we're modifying these from code, but the PV string circuit or PV source circuit, that is the input side of that DC to DC converter. So in this case, we have a single module to a single DC to DC converter, so a 1-to-1, and that input side, it's a source circuit, it's a string circuit, it's a string of 1 is what, per the definition. So that's what we're going to call it. More often you're going to just, it's a source circuit, it's the input side, and then the connections in between the DC to DC converters, those are all just DC to DC converter circuits, and then the output circuit is the same, it's just a DC to DC converter. So if you have multiple modules in series on the input side of a DC to DC converter, the definitions don't change. The way we're calling this, the string circuit or the source circuit doesn't change. And then the output of those DC to DC converters, it doesn't change at all either. So whether it's 1, whether it's 2, whether it's 4, doesn't really matter. We're going to call the input side of those components PV string or PV source circuits. And then the output is just going to be the DC to DC converter circuit. Okay, so that pretty much does it for Article 690 and the changes to scope and definitions in the 2023 code. If you are looking for more resources on this or other topics, we have classes that we get into greater detail on a variety of subjects. The workshops are all pre-recorded and self-paced. They also are available for NABCEP credits, so you can visit our website at mayfield.energy to learn more about those. And then finally, if you have questions, comments, or anything else you'd like to see discussed on our Code Corner series, feel free to reach out. Love to hear from you and be able to talk about more of these items that are as they relate to you and your installations.